Often in chemistry, you're asked to balance equations with polyatomic ions. And it's kind of intimidating at first, but it's actually pretty easy. So if we look at our equation here, we see we have this group of nonmetals here, this NO3. This is the nitrate ion. And on this side, we have the same group of nonmetals bonded together. That's our polyatomic ion. And to balance this equation, we're going to treat the nitrate, the NO3, as just one thing, like this. I have 2 times 1, 2 nitrates here and just 1 here. So I'm going to put a 2 in front of the silver nitrate. Now I have 2 times the 1 nitrate. I have 2 nitrates. They're balanced. 2 silver atoms, put a 2 here. They're balanced. Now I have 2 silver and 2 chlorine, but I already have 2 chlorine here. Calcium, calcium. That's it. We're done. So if we count that polyatomic ion as one thing, if it stays together, it makes balancing a whole lot easier. Let's take a look at some common polyatomic ions you might want to memorize. So remember, polyatomic ions made up of 2 or more atoms, and they're usually going to be nonmetals. So here's a list of 6 polyatomic ions that you'll see quite frequently in chemistry, probably worth memorizing. Your teacher might also give you a list of polyatomic ions that you're allowed to use on a test. And this is a much more detailed picture, but those original 6 or 7, I'd recommend you memorize those. So let's try to balance another equation with polyatomic ions. So sometimes it's helpful to keep track of everything by kind of writing out an accounting chart of the atoms. So I've listed all the atoms on each side here, and the sulfate right here. I have it here and here. That's because this SO4, it stays together. It's a group of nonmetals, and we have a sulfate here, and it's on this side as well. To balance it gets a lot easier now because we've counted these up. Why don't we balance the sulfate first? We have 3 here and 1 here. We put a 3 here. Now 1 times 3, those are balanced. And then we have 3 times the 1 barium. We have 3 of those. Let's balance the bariums. We could put a 3 here. 1 times 3 gives us 3 of those. 2 times 3, that gives us 6 chlorines. Let's balance the chlorines. Put a 2 here. 2 times 3, that gives us 6. Those are balanced. 2 times the 1, 2 aluminums, and we're done. This equation is balanced. So again, it really helps to count the polyatomic ion as one thing if it appears on both sides. Let's try one that's just a little bit more complicated. So I've set this one up for you. I'd like you to pause and give it a try. See if you can balance this equation. And it's probably best if you try to balance the lead first. That'll make it easier. Give it a try. So we said we'd start with the lead. We have 3 on this side and just 1 over here. Put a 3 here. 1 times 3. That gives us 3 leads. And then we have 2 nitrates times 3. So 2 times 3, we have 6 of those. Might as well just put a 6 here. Now we have 6 times the 1 nitrate. That gives us 6 of those. 6 times the 1 ammonium ion gives us 6 of those. If we put a 2 here, we have 2 times the 3 ammonium ions. That gives us 6. Those are balanced. And 2 phosphate ions. 2, we're done. This is balanced. So you can imagine if you wrote out each individual atom, this could be quite challenging. But with our polyatomic ions, it saves a lot of time. One last thing we need to consider. Sometimes you'll have an equation where you have a polyatomic ion, like the carbonate ion here, but we don't have a CO3 on this side. In this case, you can't use that technique on this type of equation. You're just going to have to write out each individual atom to balance the equation. In this case, it's already balanced, so that's kind of nice. This is Dr. B, looking at how we can balance equations with polyatomic ions. Thanks for watching.